For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Solve for the value of x that satisfies this equation 1 over logarithm of x to the base of 8 plus 1 over logarithm of 1/4 to the base of x equals -5 over 2. Now you can pause this video if you want to give this problem a try. Now, suppose you pause this video. Now let's have the solution. Alright, now one thing to notice here is this 8 and this 4. This 8 and 4, this 4 can be written as 2 raised to the power of 2, and this 8 can be written as 2 raised to the power of 3. So why not? Let's replace 8 with 2 raised to the power of 3, and this 4 with 2 raised to the power of 2. So this 8 becomes 2 raised to the power of 3, and this 4 becomes 2 raised to the power of 2. Now, let's focus on this result. And now, let's use some laws of exponent. Take note, when we have 1 over b raised to the power of a, this can be written as b raised to the power of -a. So this 2 raised to the power of 2, this can be written as 2 raised to the power of -2. So this 1 over 2 raised to the power of 2 becomes 2 raised to the power of -2. Alright, now let's focus on this result. And then what we're going to do is to write the exponent of x be equal to 1. Now there's a purpose for this one. And here's the purpose. Because take note, when we have logarithm of a raised to the power of n to the base of b raised to the power of m, this can be written as n over m multiplied by logarithm of a to the base of b. So, our terms, these two terms, this can be written as follows. So this logarithm of x raised to the power of 1 to the base of 2 raised to the power of 3, this can be written as 1/3 multiplied by logarithm of x to the base of 2. And this term, logarithm of 2 raised to the power of -2 to the base of x raised to the power of 1, this can be written as -2 over 1 multiplied by logarithm of 2 to the base of x. Alright, so now let's focus on this result. And then what we're going to do is to simplify this denominator. So our equation can be written as 3 over logarithm of x to the base of 2 minus 1 over 2 times logarithm of 2 to the base of x. Now, let's focus on this and take note of this law of logarithm. Take note, when we have logarithm of a to the base of b, this can be written as 1 over logarithm of b to the base of a. So logarithm of 2 to the base of x, we can rewrite this in terms of logarithm of x to the base of 2. So this can be written, this term, logarithm of 2 to the base of x, this can be written as 1 over logarithm of x to the base of 2. Now notice we have the same term, logarithm of x to the base of 2. So we will use this fact later on. Now, we can replace this logarithm of x to the base of 2 with another variable, and let's call this as t. So we can replace all of this term with a variable t like this. So we have 3 over t minus 1 over 2 times 1 over t equals -5 over 2. Now let's simplify this. 2 times 1 over t, this can be written as 2 over t. And then simplify this 1 over 2 over t. This can be simplified to t over 2. Now let's focus on this equation. And then what we're going to do is to eliminate the denominators t and 2. So what we're going to do is to multiply the whole thing by 2t. And if we do that, we get an equation 6 minus t squared equals -5t. And then let's equate this to 0 and rearrange some terms a little bit. So this will give us a quadratic equation 0 equals t squared minus 5t minus 6. And t squared minus 5t minus 6, this can be factored also as t minus 6 multiplied by t plus 1. Now, using the 0 property, we can equate this to 0. And we can also equate this to 0. So we can say that t equals 6 or t equals -1. Now the question, what is again the value of this variable t? Now let's go back to our solution. On our solution, we says that we let t as logarithm of x to the base of 2, because here in this question, we want the value of x. So let's get the value of t. We have logarithm of x to the base of 2. Now, let's replace all of this t with its value, logarithm of x to the base of 2, like this. So we have two cases here. We have logarithm of x to the base of 2 equals 6, or logarithm of x to the base of 2 equals negative 1. Now, to solve for the value of x, take note, when we have a logarithmic equation, logarithm of a to the base of b equals n, this can be written in an exponential form as follows. We have a equals b raised to the power of n. So, logarithm of x to the base of 2 equals 6. This can be written as x equals 2 raised to the power of 6. And we know 2 raised to the power of 6, this will give us 64. So, the value of x, the first value of x, must be equal to 64. Now, how about on the other case? So, logarithm of x to the base of 2 equals negative 1. This can be written as x equals 2 raised to the power of negative 1. And 2 raised to the power of negative 1, this can be written as 1 over 2. So, this is the second value for the variable x. Now, going back to our solution, so we're given an equation 1 over logarithm of x to the base of 8 plus 1 over logarithm of 1 over 4 to the base of x equals negative 5 over 2, and our solution goes like this. We use loss of exponent, and also we use loss of logarithm a lot, and finally we have a quadratic equation, and now solve for the value of x using this identity, and there you go. We have two possible values of x equals 64 and or x equals 1/2, and that is our answer. Therefore, given this equation, 1 over logarithm of x to the base of 8 plus 1 over logarithm of 1 over 4 to the base of x equals negative 5 over 2, then the value of x must be equal to 64 or 1 over 2. And as always, we are done.